Welcome to the first in our series of webinars about Vulcan 10. During this session, Peter and I will provide information to help you get started and also give you a brief demonstration of some new functionality. There are lots of new options in this version, and specific functionality will be discussed in more detail during future webinars. Welcome, Peter. Yesterday we released Vulcan 10 to our customers. Where can they obtain this new version?
Thanks, Steve. Probably the easiest way to do so is to go to your users area under the Maptek web page and log in with your credentials and password. And once you are in there, you should see this page, and you'll see at the very top the shiny new version 10 of Vulcan, 64-bit only, please notice. The software itself, which is about 1.5 gigabytes, and the release notes, which we also strongly encourage that you download and have a read of, because it does detail some of the new features. If for some reason you can't, handle a 1.5 gigabyte or so download, please contact your local office and we'll organise for you to get it delivered in another fashion.
Peter, I've downloaded and installed Vulcan 10, and I've noticed a new icon on my desktop, which isn't just Vulcan. Can you give us a quick tour of this new Maptek Workbench?
Sure thing. So yeah, as you mentioned, the first thing you'll see when you install it is don't go around looking for a V for Vulcan. It's actually the Maptek logo. And what that signifies, apart from the new version of Vulcan, is the entire new approach we're taking with our software and how we're going to bundle it and integrate it. So version 10 actually is by far the biggest release we've had since probably version 4, for those who go back that far. And one of the main reasons is the workbench, or the interface that packages like Vulcan runs within, has been totally rewritten. So it's now a separate product to the actual Vulcan product itself. And I'll talk a bit more detail about what that means. The first thing you might notice is, rather than have to go looking around for my various product icons for, say, Eureka or Studio, if I double click on the workbench and fire it up, you'll notice that we see all the products sitting here on this front end that I have installed. So there's a few things to note about this new splash screen. One is I have the actual application parts of Vulcan here ready to use, and they are, as I mentioned, separate plugins which talk to the new Workbench environment. If you have the plotting utility or the built-in text editor that don't require you to actually jump into Vulcan itself, you can fire them up directly from the second row of tools there. As I mentioned, rather than having to have all my applications on my desktop, they're now neatly corralled here in this installed applications area. And for things like, say, Eureka, I have multiple versions. You can actually pick which version I want to have as the default. Now, quickly, while I'm talking about Eureka, there is a free trial on for Eureka, free year, so those who are interested in having a play with this package for its geological and exploration usefulness, please let us know. Now, also, if you need to use an older version of Vulcan, they'll be there as well under what we call now Legacy Vulcan. Finally, on this page, you'll see that other products that you might be interested in but haven't got installed, you can click on these and you'll be sent to a web page with some more information. The other thing this portal does, or this start page, is we can actually have an online feed. So, as Steve mentioned, we have other webinars. You can click here and be taken straight to the page that shows you more information, or you want to know about the latest Forge. And this will be updated on a regular basis. The interface itself has some nice tools. If you want to know a bit more, you go to the tip browser. You'll get some information about the workbench and how it works. The About functionality has been enhanced, so we have all about the various products you've got installed, all about your system, should we ask you about it. If you have trouble sleeping, there's a license agreement, and we have this nice, neat memory dashboard letting you know what our applications and other applications are doing with your machine. And you'll start noticing this tabbed interface getting built up. Then obviously you have the Envisage projects you've been using recently with this nice new filter. So say I want to use something like coal to find my last thing with coal in it, I can just type that in here. Okay, in terms of getting into the product itself, it's just a matter of selecting the dataset you want to use and clicking on the icon. Now, once we're actually into the package, you'll notice the interface is different and new, but we have gone to a lot of effort to keep it familiar enough so that you can use it pretty much straight off the bat. So you still have your Explorer down the side here, you still have your menus at the top. The windowing itself is a lot more powerful than it used to be. So, for example, if I fire up something like the ISIS application, which, as I mentioned, is a separate plugin now, it will fire up in its own interface, and that interface, or any interface, can be detached, and you can sort of organize your graphics however you want them. Even if you get, say, the Envisage window and detach that, you'll notice that the icons come with the window itself. So you can put that on the second monitor and have all the associated icons you want associated with that application. I can put it back home again, go back to Envisage, let's close down ISIS and start using the software. Other things you might be aware of, worth knowing about, is things like grade control. The new grade control is the first bit of Envisage or Vulcan functionality that is a separate plugin. So it's actually a totally standalone bit of code that talks via the Workbench to the Envisage interface. And we've done that for a number of reasons. One is, from a QA perspective, it's much better to test and enhance a software plugin that isn't part of Envisage. We don't keep making Envisage bigger. We can actually, provide plugin information or plugin capability without having to touch Envisage and risk its stability at all. It also means we can deliver new content, new actual applications or products as a plugin, and in going forward in the not too distant future, we want to have these plugins available for multiple products, not just Envisage. It could be Envisage in Studio or Envisage in Eureka, that kind of thing. You'll also notice you've got keen eyes, the actual grayed out menu items here, and what that is about is, because we're capturing the conversation between the application and the interface, we can do things like start guiding the user. So I've got a brand new setup. I can't set a blast because I don't have one, so I've got to go and set up a specification or a data source. So basically we can use this to try and guide the user through the process of setting up their grade control run in this case. Now, another exciting new feature for version 10 of Vulcan is what we call command lists. So they're set up under your Customize option. If you're familiar with using the option to make toolbars, we've added a new one here called command lists. And basically, this is the start of our workflow tool in Envisage, and hopefully other products as well going into the future. So to quickly show you how that works, I can make a new list. Let's give it a new name. We call this Demo Web 1. Now, straight away, I can just have a little guide up here. This will be a workflow to make a throw fault. Oops, excuse my spelling. And then we're going to add some functionality to that. Now, I'm not limited to just using Envisage. I can use ISIS or anything in this workflow. But for the time being, I'm going to say I want you to go and create a line. So I'm going to throw that underneath my new workflow. This I can then put instructions. So make a line and call it fault 5. What do I want to do next? So next I want them to actually put a W tag on that fault for the throw. So let's go to Object Edit and grab that menu item, place it under here, and then associated with this I'm going to say, please put row 50. Okay. So once that's embedded, I can insert a pause, and I can actually put some information here. This will be used for reporting in, excuse my typing, ASM. Okay, and then finally I'm going to add the point name, because that's going to be our new dip information. So put that underneath the pause, and here please put a dip value of 120. So once I've set up what I want in my command list, I then save that, and it'll be saved to your generic customization file or one of your own choosing, and then that's now ready to use. So if I come to the command lists option, you'll see there's my new one, Demo Web. Here's a nice little interface, and if it is something I can run without any interaction in a single step, I can tick that. Otherwise, you can see this will be a workflow to make a throw fault. It's then saying make this line, call it fault 5. So I'll do that. And we're straight into the design line. As soon as I finish that, it's taken me now to W tag. Please put a throw of 50. Yes, sir. So I'll put the 50 in there. And cancel out of that. We're now in the pause, saying that's what I'm going to do with it. Terrific. Now it's taken me straight to point name. It says please make that 120. So look at that, make it 120, ready to go. Select it, done. And then once that's finished, it's actually run the command list. So I'm sure you can see that's a really powerful little tool there, which we're going to start helping new users use the software in a consistent fashion, or even just a way of saving complicated procedures in a way that can be reproduced easily. Another feature of the Workbench, which has been put not just in the Workbench but right through Vulcan, is multi-language capability. So we have this nice new widget. We can choose a language based on a region. Anything you see here in green has a language associated with it already. So if I choose Chinese, not only am I seeing the menus in the Chinese character set, but that is carried through right through the code. So layer names, block model variables, whatever you have will be put in that particular character set right throughout the entire package. And they'll appear on plot files and that kind of thing, all the outputs. So a lot of work has gone in behind the scenes to make Vulcan 10 multi-language capable. And the regions that aren't supporting the language, we've done the hard work now to support it. It's just a matter of putting in the dictionary type work where required. I'll go back to English, so I'm better at driving that. The Explorer has some nice new features too. If I want to rearrange what I see on the Explorer list, I can do that quite easily just by changing the settings here. I can also use the nice new filter options. So if you're like me and you end up with a few triangulations and I want to find one called pit, I can just type it into this filter, and now you can see the 3 files I actually want to use. So I might grab that one called pit, so I want to use it later. But that filter functionality is available for layers, for grids, and allows you to very quickly find things that might be otherwise hard to sort of find from a large list of files. Also built into the tool is some nice new functionality, built-in goodies for you. So if I select some text here in the report window, I can take that and throw it straight into a built-in text editor. So this is another little plugin, and it has some basic text editing tools to sort of allow you to go and manipulate text. If I have something a bit more structured, like I say a Lava script here, I can also throw that in the text editor, and you'll notice it's got smarts in there to highlight in different colors different aspects of the scripting language. And this particular tool does have some nice built-in parsing, as in A-R-S-E-I-N-G, P-A-R-S-E-I-N-G of the code, to allow you to even sort of quickly validate your script syntax prior to using it. If I have something that's better suited to, say, a CSV file, like a volume output, I can then grab that type of information from the report window and throw that to our little built-in CSV tool. And it's smart enough to sort of know to separate things with white space or commas depending on the input it gets. So nice little tools like that are part and parcel of the kind of thing we can do with this brand new interface. There's many other functionalities, pinnable toolbars, and you can dock toolbars within toolbars and make your own setup and save that very much to your own liking. But Steve, that's probably a good enough overview for the time being of the kind of thing you can do with the new interface.
Thanks, Peter. That's some nice integrated functionality there. I can certainly, in some of my day-to-day work, can see myself using those and saving me some time. So, as well as that new interface that Peter's just given you a quick overview, there's a lot of new functionality in Vulcan 10. In fact, as Peter said before, it's the biggest functional release of Vulcan for many years. And just as a summary on the screen there, we have put a couple of 3 different streams. Under geology, there's a new interface for generating variograms and analysing that data. We've got some new enhancements in implicit modelling, adding faults, uncertainty and radial basis functions. New fault modelling techniques for the stratigraphic horizons. Uniform conditioning is added to the geostatistical toolkit. A grey control, as Peter said very quickly before, is a new interface using all the capability of the Vulcan 10 environment. And Eureka, which is installed with Vulcan 10, which is an exploration data manipulation package that you're welcome to trial. And for the engineering and surveying customers, there's the automated pit designer, which takes an automated pit from a block model. Instead of coming up with very square looking edges from a block model, there's a nice smooth pit with all sorts of parameters based on your pit design into that. There's a couple of different tools for splitting blocks and carving up long-term designs into small scheduling blocks on both the short-term and a longer-term basis. They've got the capability now to take many hundreds, if not a billion blocks in a regular model and display all those blocks on the screen simultaneously. And the Gantt scheduler, which is our underground scheduling environment, has had a very large amount of enhancements to that environment for, largely underground, but there is some potential applications we're integrating in future versions with our OpenCut engineers in mind. Now, from a technology perspective, we have the new interface, which you've just seen, multi-threading, which has been in Vulcan before. We've expanded that capability so that now, if you're doing something computationally intensive, whether that be a big grade estimation, a block calculation, an optimization, that uses either the CPU multi-threaded at the graphics processing unit, or a new just-in-time processing, which is set up for some of our functions to get even better compilation and speeds for your processing. Menu modality is what Peter described there as in the grey control module. Only those menus that are active and current will be shown. If it's greyed out, you need to do something else to set it up to activate those menus. So it's the start of what's going to be a very intensive workflow tool that we'll be introducing into Vulcan and our other applications in the Workbench in the future. Now, we've only got limited time today, so Peter, what are your two favourite options? Can you go live and let's have a look at a couple of those?
Sure thing. So I'm biased, I suppose. I come from the stratigraphic side of things, so I'll show one for the geologists and one for the engineers. The first one is, as you briefly mentioned, we call it's a new option under open pit solids. And basically there's a bunch of new options here which would take a pit design as a solid and very quickly block that up and split it up into strip, block, bench, horizon type solids, all fully attributed, ready to go straight to a scheduler or to be exported. Quickly, there are other options apart from splitting it. Once you have these solids, you can then clip those solids to a brand new topography, and the tool will automatically do all the tidying up to make the new solids, and then you can update the attributes on those solids after you've done that exercise. You can export the attributes associated with the triangulations, and because this tool can make literally hundreds of thousands of solids, there's a nice new visibility tool to allow you to be able to see them all and pick the ones you want to look at. But the pit splitter, what used to be a possibly slightly daunting task to chop up a solid into schedulable chunks is now quite simple. I'm going to use it, and there is a dedicated webinar to this. I'm just going to show you the very quick overview even a geologist like me can use. So we've deliberately split it into two parts. One is the actual setup and one is running it. And that's because you can jump in and out of the run in a workflow basis or as you have solids ready to go. Fundamentally, there's two ways you can run it. Do you want to chop it by horizons first or by bench first? I like horizons. You can see that the actual naming of the triangulation there's a great deal of automatic control on that, which you can delve into, and also the attributing of the solids. So not the names of them, but the attributes. Things like volume and dip and surface area are now calculated on the fly and applied to the solids. How do you want to break it up in terms of your materials? This particular data set is coal, but it can be whatever you like. Do you want to set some sort of basic equipments to different materials? How do you want to deal with your projections? So you can use this just with lines and use like a B&B light, or if you have pre-made B&B projections, you can use those. Where are your horizons coming from? I've just picked a global file that populates this panel for me and gives it the various names that will appear on the attributes. How are you setting up your strips and blocks? Do you want benches? In this case, I won't. And also, all of the solids can automatically have attributes for qualities associated with them automatically from grids or from a HARP model. So I'm going to do both of those. So I've set that up. That's the spec file. Where do I want to save this? Let's call this web run1.try for the output. And basically, I need to give it the solid I want to use, and I'm ready to go. So the first thing it's going to ask me quickly is the strip lines, which I believe are these ones. Yes, and I'm going to give it a simple mining direction. And that's the naming I told it to give it. Oops. And then I'm going to get the blocks, which are these ones. Again, a simple mining direction. And this pit, has a bit of geometry to it. It has benches and pushbacks and ramps and things in it. So it's busy making a lines. It's going to start now splitting up that pit into solids by horizon. Now, while it's running, I'll show you my other favourite tool, which is the stratigraphic faulting. Now, this will take about 5 minutes to run. So I'm going to fire up the workbench again in a different data set. It might be a little bit slower this time because I'm actually running something behind the scenes, but if I go to this directory, so prior to the requirement, we all obviously have been able to model reverse and normal faults stratigraphically for a long time now, probably about 6 or 7 years using the block faulting method. That requires you to have solid triangulation zones for your faulting, and that is very powerful, especially if you have complicated geometry. But in areas where you have faults that start and stop in the middle of the design, in the middle of the modelling, it's hard to make solids of that. So now we can actually use some simple strings. And if you're familiar with the old school faulting with no dips, you put the throw on as the W tag. And like my little webinar demo of the workflow, I now want to also have in the point name the dip. And each point can have a different dip associated with it. And the direction and angle of that dip is controlled by the sequence of the string and the panel itself. So that's the entire setup for the faults. Once we're in there, I go back to my normal integrated strat modeling run. And it's really not much to show you in terms of the interface, but there's a lot of goodies behind there. So once we go to faulting and throw faulting, there's a little tick box here in 10 that says model those throws with dips. Okay, I have a convention when I'm looking along the string to say what's clockwise and anti-clockwise. I give it the seam sequence where I want to start and finish from, and what fault pertains to that particular sequence of seams. I can have many rows of these, and each one of those has a reference seam because these are angled faults, so you need to know how to pivot it. If I don't have a info or time to put the point values on point by point, I can give the entire string a dip. If I have my own triangulated planes, so not solids but planes, I can actually substitute those in certain circumstances. But basically that's it. And then in terms of running it, I'm just going to give it an output into let's call it web run1.try and let that go. So because we don't have to make an independent fault block or stratigraphic model in each of the solid domains, in fact there are no solid domains between these faults, it actually is reasonably fast to run. So it goes through and faulting by the throw and the W tag, and we're going to end up with a bunch of roof and floor surfaces as triangulations. As you'll see when we look at them, they're mainly a grid that's been triangulated, and then there's a zone where the fault has been applied within the actual surface. And unlike block faulting, these are continuous surfaces. So a reverse fault will look a bit like a Z in section, and a normal fault will look like a stretched out S or an N, I suppose, depending on how you think about it. So it's a slightly different way of modelling our faults. The beauty of this is if you need to change the position of a fault or its value, it's a CAD exercise, edit the point. So that's gone and run. Under my triangulation directory here, I should see a new folder called web run, that one there. I'm going to load up the planes first. So these have been automatically made on the fly from those strings with the angles we gave it. And you can see, if you look in there, trying to make solids of that would be fairly tricky. Right? And now we've got our faulted output. So I'll just load that up. And I'll jump into section view initially just to show you a bit about what that looks like. So let's just section it down. Okay. So as I mentioned, you sort of get this this Z shaping. So there's some normal faults there. There's probably a few. There's a normal fault there. There's some reverse faults here. You can see the fault planes going through the surfaces here. If I start dragging these around a bit, you can see how, as a fault, say this green fault here, if it hasn't hit the surface, it has no influence until it does, and then you can see it's starting to offset the surfaces. So, and you can see how the throws and indeed the dip are varying based on the parameters of the strings I used to create the faults. So here's another good one here. This fault starts having an effect until it disappears. If we quickly look at that in plan view, and I'll just load up a single surface to show you what one looks like, and I find wireframing it makes it look a bit easier. You can see how we have the gridded or triangulation of the grid surface, and then the faults have been imposed into that surface. So hopefully you can see that. Another little feature we've put into all our strat options is the ability to actually include the exact data points in these triangulated outputs, even if you're not using faulting. So you've got the option of seeing your map file and CAD data exactly represented. Okay, so that's the faulting very, very quickly. I'll jump back to our other directory here with the pit. That's all finished now. So underneath the triangulation directory here, web run 1, it's gone and given me some information. It's given me a structure here. If I look in here, it actually does a quick volume check between the horizon solids, the strip solids, and the block solids. They all match perfectly, so you should expect that. Let me just get rid of the initial solids. So initially we're going to get some solids for each horizon, so let's just load those up. And you can start seeing, I'll just quickly get rid of my my layers here, how that new filter option would come in handy once you start getting hundreds of thousands of these little solids all over the place. So here is my solids. So that's the overburden, that's a particular horizon. You can see the naming convention, if I hover over that, is now being built into it. Have E3_coal, right? So that's the first layer. If we then go back from there, we're looking at the strip solids that it's made for us. And all these are valid, and the volumes will match as we saw before. So now we're looking at the same thing, but they're broken up by strip as well as horizon automatically for you. Okay. So if you start looking at the naming convention of that, that's called V1 coal strip 6, and you can see there's a bit of equipment and stuff associated with that. Then as we get down to the block level, so further the last cut in this particular run, I've got about 1,000 of these from this run. We're now broken up by not just strip but block as well. So if I look at it in plan view, you can see I've got various blocks here, and the attribute is getting built up. You see there's the centroids and the areas and the dips and that kind of thing. And that's a burden block, but if I drill down into this and look at the next block down, that's a coal block, and you can start seeing all the attributes in terms of qualities from the heart model, qualities from a grid model, and it just built up. So if I export that, it's all that attribute is taken with that triangulation solid automatically, and it's all been done for you on the fly, and all those solids will be closed and valid. So if I do a real quick last thing here and just do a volume check, just to check validity of all those 900 and whatever it is, 13 because I deleted one. You're going to get a volume output in the report, and it's also a great way of looking at this CSV tool. So I can now throw that straight to the CSV tool, and if I scroll down through the guff here, you can see I've got a nice output I can look at straight in there. So Steve, very quickly, that's a few of my favourite things as the song goes. Is there anything you'd like to show us?
Well, thanks, Peter. If you will just share the screen with me, I'll have a look at the Vulcan Data Analyzer, which is a new interface for our customers. So the Vulcan Data Analyzer is a new interface. It's initially starting with the capability of generating variograms. So I can open a data source, which in this case is a compositing file, existing compositing file from Vulcan. Very quickly to generate a variogram, I can hit the element I want to generate the variogram of and click the button there. I'll full screen that, and I've got a variogram straight away. For those that have used Vulcan in the past for variograms, we've had 14 different menu options, individual ones. These are now all integrated into a single environment. Now, the changes I make over here into the parameters are dynamic, so as I change that, the screen updates for me. So I've got control of the lag. I make 20 meter samples, 50 meter samples, or I can just dynamically change. And everything that you do is happening in real time. So it's a significant improvement in terms of what we currently offer in Vulcan 9. Also, Vulcan does all the different variogram types at the same time, so you can just toggle between those. They're pre-calculated together, so you can choose which one you want to work with. To model the variogram, we again activate this option here. We go to a particular color, and we can do an auto fit. We can do single or multiple structures. The one I've got on the screen is not particularly useful, but you can add more structures and control that. You can do auto fit, or if you don't like the output, you've got that control then to drag things around and move them around yourself. Just wrapping up very quickly, we can also generate fan variograms. Again, it's a simple button. It takes a little bit longer this time to generate. We're generating all the variograms for around each direction. I've got 15-degree increments around there set over here. Again, I can change the lag dynamically and do modeling. Also, I've got multiple tools here to look at the semi-major and the minor axis and change those. I can also have a look at in a range of different toggle-on preset views of the variograms and the variability of the deposit for the data you're looking at. We've also have filters here, so that you've got filters and transformations. We have export, both the image data on the screen, that's what you see is what you get, and when you come to the modeling, you can export this here to once you've done the auto fit, and you can export that there to the VRG file, so that if you do a VRG file there, that'll be read straight into the grade estimation block model tools in Vulcan when you do your resource estimation. So I'll wrap that up there, because we do have a dedicated 30-minute webinar on the Vulcan Data Analyzer for those interested, and that'll be up in June. So Peter, if we just go back to the presentation, we'll wrap up with a few questions. Just following up, there's some of the first webinars and the contact on the web page there for you to go and register for those for the specific functionality. Obviously, as Peter and I have said, there's a lot of new stuff in Vulcan 10, and we possibly can't show it all in 30 minutes. So we're having a series of 10 of these over the next few months. Now, Peter, we've got a few FAQs here and a couple of customer questions. So I'll just run them past you. First of all, does Vulcan 10 work on the Windows 10 operating system?
Yes, certainly does. Vulcan 10 is going to work with Windows 10, so that's easy to keep in your mind. Just also remember that it is 64-bit only, so we don't support 32-bit anymore with Vulcan 10.
Okay, and about data compatibility, all my existing data from Vulcan 8, Vulcan 9, etc., how does that work in Vulcan 10?
Yeah, it's all fully compatible, so there's no problems with your actual data sources itself. Some files, like your screen layout files and things, will need to be either imported into the new interface and set up and saved in a new format, but otherwise all the data is compatible.
And the system requirements, Peter, you're talking about all sorts of multi-threading and things. Do I need to buy a new computer? What do we need to do there?
Yeah, I'm not sure what kind of computer you got currently, Steve, but this is the recommendation for a basic setup. So, we're looking at 64-bit, as I mentioned, a decent processor, and the more cores you can get, the better, because that allows us to take advantage of the multi-threading. The graphics card, again, we have options of use the graphics processor units, give you vastly improved speed on some options. So a good graphics card, both in terms of viewing the graphics and in doing processing now. Multiple monitors is, it's not compulsory, but we certainly recommend it, especially with the new flexibility of how the Workbench can set out how you use the software. And they've got 16 gig of RAM. That's sort of a basic. If you want to get serious, get up to 32. But basically, the best decent sort of machine you can afford without having to go to some sort of incredible dedicated high-end machine.
And Peter, there's a lot of new functionality in Vulcan 10. How do our customers, is there got to be some training sessions aside from this webinar? Where can they go to get more information?
Yeah, so there are a whole range of resources. Obviously, the upcoming webinars is one of them. There will be, your local office will no doubt be doing the usual, how to use the new version of Vulcan training. Then there's online videos, there's the release notes, as I mentioned before, the help, Forge, and other knowledge bases around the place. And of course, if you have, support is one of the things we do so well, so please just get in touch and ask a question too, and we'll certainly help you out.
Yeah, and a final question, Peter. We've been asked here, some of these new items that you've demonstrated, we've got the text editor, CSV editor, there's a new properties editor, all those new tools within that workbench. Are they going to be part of the basic Vulcan that everyone gets, or do you have to buy those functionalities?
No, they're part and parcel with it, so you'll be getting those with version 10 as soon as you install it. And obviously, I mean, one of my hats is the Workbench product manager, so any other ideas for new plugins and things, please let us know, because we're all ears and we want to really take the capabilities of this new interface as far as it can go.
Well, thank you, Peter. I think we've had a good introduction to Vulcan 10. It's out now. People can download that. Once you've done that and having any problems whatsoever, the support details are on your screen now. And if you're in Australia, there's two numbers, one for the western and one for the eastern parts of Australia. If you're one of our international listeners on this webinar, contact your local Maptek office, and we're more than welcome to help you with Vulcan 10. So thank you for listening today, and we look forward to hearing from you in the future.
Thank you all.